I think I have received some questions from Vinod sir. Let me draw it for you and then we'll discuss. The one who sent these questions, are they present or absent? Now here the question is, so with respect to, you have to identify whether it is externally determinate or not, or you have to identify whether it is internally determinate or not. And if it is not stable, then we have to identify the answer. So can you guys quickly tell me what it could be the answer? What is the indeterminacy for this? First of all, tell me whether it is determinate or indeterminate, or whether it is stable or not. Again, how come it is a stable thing, Anita?
Not stable, right? G, F, C, D. There is no triangle.
It is not stable because if you see this part, it is not forming any triangular shape.
Triangular portion.
So that's why you can simply say this is unstable. Right. When you are talking about whether it is overall the structure is stable, and still if you want to identify whether it is externally stable or internally stable, as we have discussed, external stability is coming from because of the support reactions only. So in this case, how many support reactions are developing? 3. So 3 minus 3, that will be equal to 0. Or otherwise you can say, with the combination of these 3 reactions, we can avoid the rigid body movements. And what about internal stability? As we have seen, because of the arrangement of the members in this part, it is not forming a triangular. So I can say this is internally unstable. But there is one more thing that we have to identify here is that they are asking whether it is internally determinate or internally indeterminate. So this is externally determinate and okay. It's clear, right? It is internally unstable, or we can say that the truss is unstable and it is externally determinate. But how about internal indeterminacy? How can we find it out? Whether it is determinate or indeterminate? Can I know who sent this question? Whether are you present, the one who sent this? If not, then I'll discuss in the next class. Anita, is it you that sent the question? Okay. I'm just asking just because I can directly explain it to you and others can also learn it. That's why. If the one is not here, then we can discuss later also. Otherwise, okay, forget about it. So first of all, tell me, nobody. Okay, let's discuss these questions in the next class. Whoever is present. In meanwhile, let us try to solve the reactions of determinate supports. Reactions are unknown forces or inner members. So just for the simplicity, let's start with the trusses. So let me start with the simple truss. And let us assume that there is a force acting here, 10 kilonewton, and there is a force acting here, 10 kilonewton. So first of all, if it is a truss, we know that loads will act at the joint only. And if you see the next part, on how many methods we can solve the unknown reactions in the truss. As you guys might have read it, those are nothing but methods of joints and methods of section. Right? Now, from the name itself, we can identify, right? Method of joints. That means At each joint, we will apply the equilibrium conditions and then we will find out the unknown forces or whatever it is required. If it is a method of sections, from the name itself we can identify that means instead of taking at a joint or instead of taking the entire truss, what we can do, if we can take any part of the truss, then even with that, we can find the unknown forces. So this is what the difference between the method of joints and method of sections. I will just explain you with a simple example instead of the problem that I have shown you. Let me clarify it to you a little bit more. If you are designing a truss, obviously I will agree that you guys have to find out the, or you should know what are the forces that are acting in the truss, each and every member. But if you are going for the competitive exams, then it might not entirely require forces in all the members. They might ask you some member only. And let me tell you in that case, which one we have to use. Let us consider there is a truss A, B, C, D, E, F. First of all, tell me whether it is determinate or indeterminate. By looking at the truss, we can identify, isn't it?
Determinate, sir.
Determinate. Support reaction, and even if you remove any one member, it's not forming a triangular shape. So that's why these are the determinate case. Suppose in the exam, let us say that they have asked you to find out the force in the member BE. In the exam, they are interested in only finding the force in the member BE only. Then, is there any point in the exam to find out the forces in other members? No, right? At least in a least possible way, we should able to find out the force in the member VE. Even if you find out the forces in other members, then again it will be the waste of time. So if in the exam they ask you to find a specific force in the member or some members, instead of one, they might ask you for two members or they might ask you for three members. So in that case, you have to go for the method of sections. Before that, before going on to further discussions, as these are the truss members, then they will resist which type of forces?
Only axial force.
They will resist only axial forces, isn't it? So how can I describe the axial force? Either I can describe it by it is a either the members are in tension, or I can describe that it can be under compression, isn't it? And as I told you in the previous classes also, every time it is difficult to represent or say that direction of the force. As we are talking about the internal arrangements of the members, we are not talking about the support reactions. As we are talking about the what will be the reaction of the members due to the applied forces, we can say whether they can be under tension, whether they can be under compression. But while again in calculating, but again it will be difficult. So if it is a tensile force, in most of the cases we will represent it with positive. So for any member, if I say that force in the member is plus 10 kilonewton, that plus represents that in the member it is under tension. Similarly, if it is under compression, then let us identify it by using the negative sign. So if there is any force, if I say to you minus 25 kilonewton, that means that minus represents that there is a compression acting in the member. Right? Now, so this is the first basic thing. And coming to the second thing, how to represent a force in the member. Let us say, if I want to draw the free body diagram at point B. So let me consider this is my point B. So initially, you have to assume that what is the behavior of the member, whether it is under tension or whether it is under compression. That is what we does all the time. So in generally, even your textbooks or even your regular courses, we will follow that. Initially, we will assume that the members are in tension. And you can say, if you are getting some opposite sign, then you can say that my assumed direction is wrong. Then you will change the direction. So even here also, at point B, first I will, how many members are connected at point B? 3 members, isn't it?
Three, sir.
A, member BC, member BE. As I'm talking about joint B. First, I am assuming that all these 3 members are under tension. That is what my initial assumption. So the next thing is that how to represent that force, tensile force. First thing is that if I want to represent a tensile force in BC, what you should do? First, draw an imaginary line along the member BC. Draw an imaginary line along the member BC and then represent a force that is away from the joint. So in which direction I should represent if it is away from the point B means along this line?
Right side.
I have to represent it on the right side. So if you want to represent a tensile force in the member BC, draw a line along the element and then represent an arrow away from the joint. So this is what my representation of the tensile force. Let us assume that this is my force in the member BC. Similarly, if I want to represent the tensile force in the member BA, what is the first thing we have to do? Draw a line
Imaginary thing.
along the element and then represent an arrow away from the element. So in this
Left
case,
side.
if I represent left side, that is only away from the element. So this is what the representation of tensile force in the member BA. Similarly, at BE, so first of all, I will draw a line again on the same thing. I will draw a line along the member BE and then I will represent an arrow away from the joint. So this is what my force in the member BE. As of now, is it okay? How to represent a tensile forces in the system for everybody?
Yes, sir.
Now,
sir.
now, as I am talking about the equilibrium at a joint, if it is to be stable, right? Obviously, if it is to be stable, it has to satisfy the equilibrium equations. As we have already discussed, as we are talking about a point, if I am talking about XY plane, how many equilibrium equations I should consider?
Sir.
As it is generally, it will be summation of x equal to 0, generally summation of y equal to 0, and generally summation of movement is equal to 0. But as you can see, these members are connected at the joint. As three members are passing through the point B, then movements will not generate. As movements are generating, then there is no point of using this equation. That's why we can cancel it down. So not only here, even whenever you are talking about, unless and until, if there is an external movement acting, then it should not be equal to 0. If you have to consider. So that is what the possibility for plane systems. But for the truss cases, as there are only axial forces are existing, no concentrated moments will also generate in the truss cases. That's why you can kindly ignore this equation. Now, at the joint B, if I draw the free body diagram at joint B, how many unknowns are existing here? How many unknowns are there? Joint B,
3
isn't it? FBA, FBC, and
BC FB.
and how many equilibrium equations are possible here? 2.
2, sir.
2 only.
How many unknowns we are having? We are having the unknowns
3
FB, FBA, and FB.
FB.
But we are having equilibrium equations are 2.
2.
That means can we find these unknowns?
No, no, sir.
No, isn't it?
Yes.
That means how many extra equations we need?
1.
One extra
One.
equation we need.
Yes.
Isn't it?
Yes, sir.
Suppose at joint B, if I represent the forces are like this only. Let us say this is FBA and FBC. There is no FBA. Can I
But
find
we
these two
take
forces?
the
Are,
limit equation, sir.
Yes, sir.
why?
Yes, sir.
Because I am having two unknown forces
Two
and
equilibrium
two
equations.
equations. That's why I can solve that.
Yes, sir.
Instead, now how many members are connected at this joint right now?
4.
4, right? How many equilibrium equations? 2. Can we again solve it? We cannot, right?
Yes, sir.
By using equilibrium equations, we cannot. If we want to get all these forces, then how many extra equations we need then? That means if we're talking about joint B itself. Now, from these 3 examples, can we understand one thing? That if you are drawing the, or if you want to consider free body diagram at any point, then you have to make sure that number of unknowns should not be more than 2.
2.
Is it clear? That means whatever the
Yes, sir.
joint you are considering, you have to make sure that number of unknowns should not be more than 2. Why? Because if number of unknowns are more than 2, then equilibrium equations itself not sufficient.
No, sir.
Just like in this case,
Yes, sir.
unknown forces are 4, but we are having equilibrium equations 2. That means we cannot solve all these 4 forces. So this is the initial start, that from now onwards, whatever the joint you have considering, you have to make sure that number of unknowns should not be greater than 2. So this is what the basic funda that we have to understand if we are going for the method of joints, right? Now, let us assume or let us solve this simple case and then we'll go for the other part. So that's why I'm just separating this section. Again, I'm redrawing that part. So let us assume that, let me give you a tree. Imagine that there is a force acting like this, 10 kilonewton. And this is what your king support, and this is what your dollar support. So the first thing in generally we will do is that we have to find the support reaction. Or first question you can ask me, is it always true that I should always start from the support reactions? I can say in most of the cases yes, but the answer is no. Why? Because let us say if you want to consider free body diagram at point A, can you tell me how many forces are existing at point A?
3.
Imagine, as of now, imagine that we haven't found out any support reactions. If you start from A, how many unknown forces will exist? If you start the equilibrium at joint A, how many members are connected?
3 members are counted.
3 members are connected. So forces in those 3 members are unknown. That means,
Yes, sir.
can we find forces in any? Can we or we cannot? Because how many equilibrium equations we have at a joint?
2. 2, sir.
That's why we cannot start from joint A. Is
Yes,
it-
sir.
Similarly, go to the joint B. Again, how many members are connected?
3 members.
But we have
Little
to,
bit difference 2. So not.
yes, there are more than 2. Again, I cannot start from B.
Yes, sir.
Similarly, even look at joint C. Again, 3 members are connected, so I cannot start directly from C. Even if I look at point E, how many are there? Total 5 members are connected at
2,
point
sir.
E. At E, 1, 2, 3, 4, 5.
Oh, sorry.
Even again,
Yes, sir.
I cannot start it from point E. Can you tell
Yes,
me at point D, how many unknowns are there?
2, sir.
Is it only 2 or more than 2?
Yes, sir. Only 2, sir.
5.
2 are coming from, one is for the member A, one is member for the D, but you are
Reaction.
having the support here, right? You will develop reaction from the support too. That means how many reactions will develop at D?
2,
Vertical
sir.
will develop, horizontal will develop.
2, sir.
So if I draw
Vertical
the
and
three-body
horizontal.
diagram at point D, so if I draw the three-body diagram at point D, total how many unknown forces will exist?
4.
4, sir.
Force in the member AD, force in the member DE, and 2 support reaction.
Yes, sir.
Similarly, at point F,
And yes, sir. 3 unknown.
3 unknown, sir.
3 unknowns. So
3
again,
unknown, sir.
if you draw the three-body diagram
FC.
at point F, we cannot find it out.
Point.
So that's
Yes,
why in this case, directly if you want to start it from equilibrium of a joint, you cannot solve it. Why? Because at every joint, number of unknowns are more than 2. So again, look at the support reaction. How many unknown reactions will be there at support? There might be unknown reaction will develop here. Let us say this is the vertical reaction at D. Similarly, there will be horizontal reaction at D, HT. Similarly, there will be a vertical reaction at F. Now, again, how many unknowns are there? 3. So, if I consider equilibrium of my entire truss, can I find these 3 unknowns or not?
Yes, sir.
Always remember, if I am considering equilibrium of entire truss or some part of the sections, then how many equilibrium equations will exist? Summation of x equal to 0, summation of y equal to 0, and then summation of moment is also equal to 0. Well, if I want to write summation of forces along y equal to 0, now how many forces are there along y direction?
2, sir.
Look at the entire curve, only 2.
2,
Right?
sir.
That
VD and
means
VF, sir.
I can say
VD and VF.
Vf is equal to 0. Isn't it?
Yes, sir.
Similarly,
Yes, sir.
if I see summation of forces along x equal to 0, how many forces are there total?
2,
2, sir.
2, sir.
2. 10 kilonewton and
HB
support
plus.
reaction. Imagine that if right side force is positive, then what I can write it down?
Yes, sir.
Less 10
HDB is 10.
plus. Initially, I am
10
assuming that my
plus
HD is
HB.
also acting on the right. So
Yes, sir.
HD is equal to 0.
Equal to
That
0.
means what I will get finally my HD as minus
Minus
10
10.
kilo. What does this minus represents?
10, sir.
Is it that's what I'm
Comparative
telling
side.
you? No. This is not a force in the member. If it is a force in the member, then only you will say it as either tensile or compression. Is
Yes,
it a force in the member? HD, is it a force in the member?
No, sir.
It is a support reaction. If you are talking
Yes,
about
yes,
the
yes.
support reaction, you will just say that in which direction it is acting. Initially, what is the direction we are assuming? Initially,
Right,
we
sir.
have assumed that it is acting in the right side.
Right side, sir. Right side.
As we are getting in the negative, that means our assumed direction is wrong. That
Left
means
side,
we
yes,
have
sir.
to
Yes, sir, yes,
represent
sir.
it in the opposite reaction. So
Yes,
I will represent my reaction HD as equal to 10 kilonewton. As I remove the sign, here I should represent the direction. What is the direction I should represent? Left side.
Left
As
side.
of now, no doubt, isn't it?
Clear.
Yes, sir.
Yes, sir.
Then
Clear,
let us
sir.
say consider the moment at any point is equal to 0. Sorry. Moment at any point, summation of moments at any point. Now the question is, can you tell me in which point I can consider the summation of moments equal to 0? Out of these 6 points, let us say A, B, C, D, E, F. Out of the 6 points, can you tell me what might be the best point? Or instead, let us say that I'm writing, first of all, summation of moments at point E. Let us assume that clockwise moments are positive. Okay. Now tell me the summation of moments at this point.
VD.
Tell me because of this 10 kilonewton. Let us say this is this 3 meter, 3
10 into
meter,
3, sir.
10 into 3, right?
Yes, sir.
30. And it is in which direction? Clockwise or anti-clockwise? Movement at this point,
Clockwise, sir.
clockwise. So let us assume that clockwise are positive. So if I assume clockwise
Yes,
are positive, then here I will say plus
10 into
30.
10 into 3.
Because of the reaction F, what is the moment at point E? Moment will come or not? Because of the VF, what is the moment at point E?
VD. VD into 3.
Because of VF, VF into 3. Clockwise or anti-clockwise? Anti-clockwise. As it is anti-clockwise, I will say minus 3 times VF. Because of this VD, what is the moment at point E? Will it come or not? Because of VD, moment will generate at point E or not?
No, sir. No.
Why? How you will find the moment? What is the moment? Moment is nothing but force into perpendicular distance, isn't it?
Yes, sir.
Now, we are talking about summation of moments. Here, let me write it down. What is the moment at point E? If I look it from right, and similarly, you guys also have to tell me what is the moment at E. Those who already have clear idea about this, please follow me because it has to be clear. Now, what is the difference between summation of moments and moment at point E?
Summation moment at E, all the moments, sir. Moments
It is
at E,
summation.
right?
We have to look into all directions.
All
Directions, and then you have to find out the equation. But if I'm talking about simply movement, that means you should look into only one direction,
left side.
always one direction. So as I'm talking about summation, we have to look into all directions and we have to see the all possible movement. Now, because of this VD, what is the moment at point E? VD into perpendicular distance is 3. So VD into 3. Again, it is in clockwise direction. As it is clockwise direction, plus 3 times VD. Because of this HD, will there be any moment at point E?
No, sir.
Why? Because this HD will pass through the point E. As it will pass through the point E, line of action of HD. As it is passing through E, there won't be any moment. So this is what the equation if you are speaking about moment at point E. Similarly, can you tell me what is the moment at point E if you look into the right side? And now I'm not talking about summation of moments. I'm just asking you what is the moment at point E? And tell me if I'm looking at right side.
10 into 3 minus VF into 3.
Is it right? Just imagine that. Just like there is a famous dialogue with Balaya, like will say, Chudu, I don't know. There is some famous dialogue in Telugu. You have to look into only one side. So if you at point E, look into the right side. How many forces you can see? If you look at point E, if you look into the right side, 10 kilonewton is visible. VF is also visible. So because of the VF, what is the moment? VF into 3. And because of this 10 kilonewton, 10 into 3. Because of the VF anti-clockwise, so minus 3 times VF because of the 10 kilonewton positive. Similarly, if you look into the moment at point E to the left side, if you look into the left side, how many forces are existing? HD is existing and VD is existing. HD is passing through the point E, so there won't be any movement. Because of the VD, VD into 3. Again, it is in the clockwise direction. So that is what the difference between movement and summation of moments. Hope it's clear for you. Now, what happens here? By using this equation, can we directly find either VF or VD? By using this equation, what is happening? This equation consisting of how many unknowns? 2 unknowns, isn't it? VF and VD. That's why I cannot directly find out either VF or I cannot find out the VD. But instead, what if I write it down, my summation of moments at point A is equal to 0. Not at point A, point B. Can you tell me what is the equation you will get if we take summation of moments at this point? Because of the HD and VD, will there be any movements at point D?
HD in 3.
HD,
In 3 into 3.
there won't be any movements at point Y because these are passing through this point. Now, because of VF, what is the moment? VF into 3 plus 3, 6.
6.
So total 6 into VF. Again, it is in anti-clockwise. So I can say, as it is anti-clockwise, I am treating it as negative. So minus 6 into VF. Because of this 10 kilonewton, 10 into perpendicular distance is 3. It will be clockwise movement. So plus 10 into 3 equal to 0. Now, this equation consists of how many unknowns?
1.
1. That means we can find out that unknown, isn't it?
1, sir.
So that is what the difference between these two. So whenever you want to apply the equation, summation of moments is equal to 0, then what do you think? Which one you will prefer? Will you prefer this one or will you prefer this one? First one or second one?
Second one, sir.
Why? Because if
there
you are
is
using
only
second one directly, we are getting one unknown. So this is the funda that generally people will consider summation of the moments at support point is equal to 0. Why? Because if I am taking the summation of moments at this point is equal to 0, my equation will consist of which unknown? VF, isn't it? If you
Yes, sir.
consider moment at point D equal to 0, my equation is having which unknown? VF. Similarly, if I take moment summation of moments at point F equal to 0, can you tell me my equation will consist of VD,
Yes, sir.
isn't it? So that's why if you are taking summation of moments at any support is equal to 0, at that support, moments will not generate. As they will not generate, they will be not coming to the picture, and then the another unknown we can easily find it out. So that's why whenever you want to find out the summation of moments equal to 0, that make sure that whether you can find out any one unknown or not. That's it. So in this case, at E, I won't prefer, instead I will prefer either at point D or at point F. Both are fine. So if you solve this equation, how much you will get? VF. This 30 will go.
24.
-24, sir.
24 plus 20.
20
Minus 24, sir. Minus
sir.
27.
minus 24.
5, sir. 5, sir. 5, sir.
5. What equation you are solving? 10 into 3. You go to the right side.
Sorry,
Minus
sir.
30.
Minus. Sorry, sir.
Minus 30 by minus 6. How much you will get?
5, sir.
5, sir. 5.
Positive or negative?
Negative, sir.
Positive. What does it represent? Positive here.
The direction right.
Our azimuth direction is correct. What is azimuth direction here? Initially, we are assuming it in upward direction.
Yes, sir. Yes,
That
sir. Yes.
means my azimuth direction is correct. This force is also acting in the upward direction.
Four direction.
Similarly, already we have written this equation. Summation of Fy equal to 0. That means what you are getting? Vd plus Vf is equal to 0. That implies what is my Vd? That is nothing but
Minus 5.
minus Vf. What does this minus represents? Again,
Downward direction.
my azimuth direction is wrong. What is my azimuth direction? Upward.
Upward.
Instead, what I should consider? I should treat as
Downward.
5
Down.
kilometers downward direction. Is it okay?
Yes, sir.
Yes, sir.
So after that, what you have to do? You have to represent the forces here. Now, what is the force acting here? I represent this in different colors so that it will be easier. So here it is 10 kilonewton, and at this point it is 10 kilonewton. At Vd, it will be acting in the downward direction. 5. At this point, it will be acting in the upward. 5. It's clear, right?
Clear, sir.
Yes, sir.
Now, let me solve this problem much easier than to the previous one. See, here, it's not, don't go blindly with the equations and let us visualize the things. What is happening here? Now, for me, this entire truss should be stable, isn't it? Now, because of this force, how can I balance it? As my 10 kilonewton applied force is acting on the right. Obviously, if it is to be stable, all the forces along x direction should be 0. All the forces along y direction should be 0. And net movement should be equal to 0, isn't it? So let us think in a, here the force is acting in which direction? Let us assume that it is acting in the x direction.
Yes, sir.
So if it is to be stable, then my net forces along x should be equal to 0. Now tell me, how can I make the net forces along x direction is equal to 0? There is some force 10 kilonewton that is acting at one point. How can I balance it? And at what point we have to balance it? Here, which one we have removed? We have removed the supports. That means it will be balanced through support reaction, isn't it?
Yes, sir.
Yes, sir.
Now the next point is, at D it is a hinge support, isn't it?
Yes, sir.
And at this point it is a roller.
Roller support.
Now tell me, so at which point the reaction force will develop? At point D or at point F?
Point D.
Point D,
Because
sir.
this is only will resist the horizontal forces too. As it is a roller, it won't resist. Now, can you tell me directly what can be the direction? Here
Left
the
side.
force is acting on the right side. How can I balance it?
Left side, sir.
The force
Left
in the
side.
opposite direction.
Left side.
Instead of doing any calculations, here I am saying that my 10 kilonewton is acting on the left. Is there any need? So now see, I know by looking at this truss, as 10 kilonewton is acting on the right side, I know that at point D initially it is acting on the left side direction. But just to show you, purposely I have mentioned it on the right side, just because your visualization should be clear. So from now onwards, until and unless if I know directly, I will represent the reaction forces along the depending upon the types of forces acting on the system. So from now onwards, you should not blindly always represent it is acting on the right or left. First, you should say, okay, what is my applied load direction? 10 on the right. So the support reaction should balance. That's why, okay, here there may be left side force might act. As of now, clear about HD and its direction, how to represent it directly without any equations, right? Now, look at these forces. Look at this 10 kilonewton and 10 kilonewton. Look at this force. What are they trying to do with the system? Can you identify? Or can you identify which type of forces are these? Are they separated or are they acting on the same line of action?
Same line of action.
What is mean by line of action? If I apply force like this, line of action means draw a line along this. And this is where my 10 kilonewton applied force is acting. And this is where my horizontal reaction is developing. So these two are separating by how much distance?
3.
3 meters. That means these two will act like a
Couple, mama.
Couple.
because of this 10 kilonewton and because of the resisting force 10 kilonewton, these are trying to generate a moment of how much?
30.
30, 10 into 3, isn't it?
Sir. Yes,
Along which direction?
Clockwise.
That means because of the arrangement of these forces, my truss is now having unbalanced moment of how much? 30 kilo in which
30
direction?
Clockwise direction.
If it is to be stable, do we have to allow it? We don't, right? We have to balance it. Hence, because of these two forces, there is an unbalanced moment of 30 kilonewton meter, and it is trying to rotate your truss in the clockwise direction. How can I balance it? How can I balance it? By generating some
Making
anti-clockwise movement, isn't it? As these two are generating a clockwise movement of 30 kilonewton meter, to balance it, I will try to compensate or I will try to make some arrangement such that they will produce a magnitude of 30 kilonewton meter in the anti-clockwise direction. Now, these are truss members, isn't it? As these are truss members, I cannot represent anywhere anti-clockwise 30, isn't it?
Yes, sir.
Then how can I still balance those unbalanced movements? Are there any other forces? They will be encounter movement also. See, if I represent a force like this, movement will generate or not at any point in the truss because of this force.
0. Moment will be 0.
At, okay, movement is 0, but still because of this force, movement might generate. So here, this unbalanced movement will be balanced by the support reaction.
Okay,
But
sir.
any other vertical loads acting on the system?
No, sir, not possible.
No. But we have to balance this. As there are no other forces are acting on the system, then I can say that if I represent a force like this, and if I represent a force like this, let us say this is also 5 kilonewton, and this is also 5 kilonewton.
Yes, sir.
Add the forces along vertical direction, how much you are getting?
0.
0, isn't it? That
Sir.
means if there is any unbalanced movement is acting, you can balance it by using support reactions.
Support reaction.
Also. Now, if I consider support reactions are like this, can you tell me in which direction these are causing the movement? These are like a couple, isn't it? Equal and
Yes, sir.
forces, separated by distance how much?
6.
6 meters. Now these two are generating which movement? This force and this force, these
Clockwise.
are generating clockwise movement. But
Clockwise.
in the present case, these 10 kilonewton are generating the clockwise movement. But how much moment we should get? These support reactions have to generate which type of moment? Clockwise or anti-clockwise?
Which one you ask, sir?
These support reactions, 10 kilonewton and 10 kilonewton, these are trying to rotate your member or you are trying to rotate your truss in clockwise direction. That's why
Yes, sir.
your support reactions have to make anti-clockwise movement.
Yes, sir.
So, if I represent a force here, let us say unknown force as P in the downward direction. If I represent there is a force here in upward direction, then these two are separated by a distance 6 meters. Now you can understand movement, unbalanced movement generated by 10 kilonewton force is balanced by the
Support
vertical.
reaction. Support.
Then how can I find out this magnitude P? What is the movement that is generating because of the P? P into 6,
P into particular distance, sir.
6P. So this is anti-clockwise. That should be balanced with the unbalanced movement. What is the unbalanced movement? 10 into 3, 30.
30.
That implies P will be is equal to
5.
So my this P is 5 and this P is equal to 5.
Yes, sir.
As you are starting this problem, you might face difficulty for understanding this, but if you understood this logic, then finding reaction forces will be in a couple of seconds only. Instead of writing these equations, what I will do, okay, as this 10 kilonewton is acting on the right side, I have to balance it. So that's why I will balance this by representing a force here on the left side. Okay. Then, but these two are generating a unbalanced moment of 30 in clockwise direction. Again, I will think in my mind that that has to be balanced, and that will be balanced by using the vertical support reaction. So I have to represent the forces such a way that they should represent the anti-clockwise direction. And how much the magnitude will be? Again, 6 into P, that will be equal to 30. So P equal to 5. So that is how, through understanding of the mechanics, I can represent the, without writing any equations, I can find out the support reactions too. I don't say that this is possible for all types of members. It may not. There are some trust problems or there are some big problems, they might be difficult to understand. But with this logic, for some problems, you can easily find out the support reaction. Is there any doubt in this logic? How we have represent the forces without equations?
Clear, sir.
Clear, right? So let me hear from others too, as I think Anita is only responding more.
Yes.
Please try to speak. If there is any doubt,
Yes.
Yes.
if not, can I give you a simple problem? Can you tell me whether it is determinate or indeterminate?
Determinate.
Determinate, sir.
Determinate? No,
Yeah.
it is indeterminate.
Why, sir? It will be removed on member BC. They can form
Anybody
triangle.
can try. Anybody can try it, whether it is determinate or indeterminate, other than her.
How, sir?
Any others can try it.
Sir, you can say they are removed and BC members, so they can form only triangles. That's the reason for I'm telling determinate.
What about others? Can you guess
-1.
whether it is determinate or indeterminate?
Indeterminate, sir.
Indeterminate. Why? Why it is indeterminate?
Same.
Come on, think about it. Don't be keep quiet, just think about it and tell me. Yeah.
I'm getting -1, sir.
Sorry, yaar, your no voice is not completely audible to me. Can you tell me once again, or can you please type in the chat box? Determinate or indeterminate, just raise your hands or just type it. Who guys will agree with determinate and who will agree with indeterminate?
So my side determinate.
Okay, and let me go to the participants and let me see who is speaking. Okay. And then others? Only one. Okay. And the spoke. Determinate for according to Anita and remaining 4 or remaining 3. I need answers from you. Priyadarshini,
Determinates, sir.
determinate according to you. Okay, fine. Vishnu Bhupati, determinate or indeterminate? Okay, you are getting -1, right?
Yes, sir.
How many members are there? 1, 2, 3, 4, 5,
10 numbers, sir.
7, 8, 9, 10.
Yes, sir.
How many reactions?
Sir,
Please, sir.
How many reactions?
sir,
Please,
so
sir.
this 10 kilonewton is balanced by the forces developed in at the point A. So there is no moment is generated. So we couldn't we can't find the forces at the F. That's why are you telling this structures is indeterminate, sir?
No, here the thing is that I just given some random trust. So here we cannot directly find the reactions. Why? Because here 10 kilonewton is acting like this, isn't it? So this will be balanced by here horizontal reaction generated by here and horizontal reaction generated by here, isn't it?
Yeah, yes, sir.
Can you tell me how much portion it will resist here and it will resist here? That means out of 10, okay, 5 will take here, 5 will take here. Like that, can we quickly judge it by looking at this truss itself?
Sir, you can say again, please, sir. I'm not audible, sir.
So if I give you in the another case, if I tell you my support reaction at A is like this, what is the difference between this case and this case? If there is a force acting like this, 10 kilonewton.
It cannot resist on horizontal force because it is vertical.
So here it cannot. But what is the horizontal reaction here?
Hinged support. Yes, sir.
Left
Opposite
side
direction.
10.
Left side.
10, sir.
Again, these two are in couple type of thing, isn't it? And to balance this, these are trying to rotate your member in which direction, clockwise or anti-clockwise?
Okay.
That means
Clockwise, sir.
your support reactions have to make which movement? Anti-clockwise.
Anti-clockwise, sir.
Or anti-clockwise, this should be downward, this should be
This
upward.
be upward. Yes, sir.
But instead this case, this can be resisted by at support A and at support F also. So in
Yeah.
this case, we cannot speak directly.
Oh, okay, sir.
So instead, if I am giving the problem, it doesn't mean that it will completely sync with the previous case. Obviously not. I might give, I might not be give, but if support reaction is like this, then we can.
Okay, sir. Okay, sir.
Now, let us come to this stress. Now tell me, if I want to find out the forces in the members, from which joint I should come from? From A I should start, or from B, or from C, from D, or from E, or from F? From which side I should start it?
E, sir.
E.
Yeah.
At
Sir?
E, how many members are connected?
Sir,
5, sir, connected, sir.
Yeah, please.
So have you completed the second one, that is determinate or indeterminate?
No, that's not indeterminate. I just going in a wrong way only to confuse you.
Okay, sir.
Okay, don't get deviated with my answers. Okay, whether it is determinate or indeterminate. Sometimes I might give you wrong so that you guys can think and recorrect me. So that's how it should be. Thank you. At
Determinate
least
structures.
nobody. Yeah.
Okay.
Okay, now why I should start with E? At E, how many members are connected?
5 members are connected, sir.
Then we cannot, isn't it?
Yeah.
That means if you look at D, how many unknowns are there?
4, sir.
Yes.
Not 4. At D,
Uh,
already we know this reaction is 10. We know that
I-
support reaction is 5. Now, how many
Yes,
are
sir.
there?
2,
Two.
sir.
Two,
2
sir.
only.
That means I can start from joint D.
Yes,
Really
sir.
look at F. How many unknowns are there?
Support E. You will ask support
At
E. Sir.
F. No, at F. At F again. How many unknowns are there?
Two, sir.
2,
So,
2, sir.
so can I start from F also?
Yes, sir.
That means in this case, either I can start from D or I can start from F. Right? Now, if I start from D, again, if you're talking about equilibrium at joint D, there is a external reaction 5 that is acting in the downward direction, and there is a support reaction 10 kilonewton that is acting on the left side. Now, let us assume that again, member AD is under tension. If a member AD is under tension, then I will draw a line along the line of action, and then I will represent a force away from the joint, away from the joint. So this is what my force in the member D.
FD.
Similarly, for finding the force in the member D,
FD.
similarly,
Away
I
from
will
the-
draw a line along the member, and then I will represent an arrow away from the joint. So this is what my force in the member D. Now, can you directly tell me what about these values? What is FDA and what is FDE? What are the equilibrium equations? At the
Summation
joint,
fx equals 0.
summation
Summation
fx
fy
equals
equals 0.
and then summation fy is equal to 0. Look at along x direction. How many forces are there?
Two, sir.
2.
And
That
y
means
direction
what can
2.
be my FDE then?
FD
That can be
plus 10.
to balance it, FDE obviously should act on the right.
Yes, sir.
Then what should be this magnitude then?
Plus 10.
Magnitude 10 kilonewton, right? Similarly, 5 kilonewton is acting in which direction?
Downward direction.
Up.
So FDA will
Balance
equal
it,
to 5
FDE
kilonewton
should
upward
acting
direction.
upward.
Plus.
Again, what
Plus.
could be magnitude? So instead of writing any equation, is it okay now here in this case?
Yes, sir.
Sir, is it okay, sir?
Now, let me rewrite this problem. Instead, what I can say, 5 kilonewton, 10 kilonewton, and this is what my member FDE, and this is what my member, imagine this is what your member FTA, and let us assume this is what my angle alpha. Or with the understanding in which direction I should represent the force in the member DE.
Right side, sir.
Look at the force. Force is acting on the left side.
10 kilonewton are left side. So
to balance
we
it
can-
generally. So this
right
is
side,
how
sir.
if you represent it in the case, then you might agree with positive or negative. So this is how I will represent FD. Now imagine that if there is a force acting like this FDA, imagine this angle is alpha. Now first of all tell me what the difference between these two cases.
First case there won't be any incline.
That means in the first case, all the forces are perfectly oriented along the X and
Yes, sir.
Y direction.
Yes.
That means we can directly able to find out what is the magnitude of FDA and what is the magnitude of FDE. But in this case, because of which component we are having the problem?
FDA and inclined
FDA,
force
sir.
sensor.
FDA. Why? Because it is an inclined force, isn't it?
Yes, sir.
Yes,
So
sir.
after that, to solve it, what you should do? You should resolve this force, isn't it?
Yes, sir.
Yes, sir. Yes.
If you resolve this force, what is the component you will get it?
Vertical FDA
FDA
sin
cos
alpha.
Angle is with respect to X. So here, what is this component? FDA
FDA sin theta and
sin
y
alpha.
direction.
And what is this
FD
component?
sin alpha.
Yeah. Cos alpha FDA cos alpha.
Now, which one I can find it out directly here after this? 5 is acting in the downward. FDA sin alpha is acting in the upward. So what will be my FDA?
FDA
Can I directly say?
5 by sin
5 by
alpha.
sin alpha. Yes, sir.
What about along X direction? For X direction, obviously I have to do
Yeah. DE
FDE
equal to
plus
5 by cos alpha.
FDE
10 by
cos
cos alpha.
Sorry. FDE is acting on the right. FDA cos alpha is acting on the right. That will be equal to 10 kilonewton. Is it right?
Yes, sir.
That means out of these two unknowns, if I write this equation or if I write this equation, which like if I write this equation first, can I know any of this component?
No,
That
sir.
means in this case, if I write summation of force along y equal to 0, then I can directly find out the FDA.
Yes,
After
sir.
that, if I apply this equation here, I can
Summation
find out
Fx equals.
FDE.
Yes, sir.
That means depending upon the orientation of the members, sometimes you guys have to think that first of all, which equation if I write it down, I can directly find out the force. So that way also you guys have to practice. Instead, my FDA is acting along F. If I say that my FDE is inclined. Now can you tell me which equation I should write first? Summation Fx equal to 0 or summation Fy equal to 0?
Summation Fy equals 0.
Summation
Fy equals 0.
Why Fy is equal to 0?
Because we have to resolve FDA in
If you
x
resolve
direction and y
along y
direction. So,
direction,
yes,
if
sir.
you resolve along y direction, what is the equation you will get? You will get FDA
FDA plus
Plus
FDE sin
sin alpha
alpha
is equal to
some 5 kilonewton.
Are you getting any this unknown by using this equation?
No, sir.
No.
Then why you will use summation Fy equal to 0 here?
Uh,
Instead, look it along the X. Along X, how many forces are there?
2.
2, sir.
10 kilonewton. And FDE will have any? No. Because
No.
of this inclined force,
Yes, sir.
FDE cos alpha.
Cos alpha. So we find it
That means,
FDE.
yeah. It's not wrong if you write summation Fy equal to 0 first. It's not at all wrong. Even it's right. But the thing is that if you directly write the equation which gives you the force directly, then that will be better.
Yes, sir. Clear.
Okay.
Understand, sir.
Now
Yes,
it's
sir.
clear, right? Which one we should go first? That is
Clear.
just based upon you guys have to look at the orientation of the members and you guys have to see, okay, along X or along Y. Okay, and then which one I should write down first. Initially, it may take some time, but if you practice it, it will be much easier. Okay, clear?
Clear, sir.
So all this is unnecessary stuff, but okay, let me keep that stick. Now I done with A. Can I go to A? If I go to A, now how many unknowns will be there?
3, sir.
Even though 3 members are connected, I already know the force in member AD. So that's why
2 unknowns,
I
sir.
can find it out, right? So at point A, first of all, I will represent the force that I have known already. What is that force? FDA. Now tell me, which force is it? Is it a tensile force or compression force?
Tensile.
How to represent the tensile force in AD? Draw a line along the member and then represent an arrow away from the joint. So this is what your force 5 kilonewton. Similarly, AB is along horizontal direction. Again, I will assume that it will be under tension. How can I represent? Draw a line along the AB and then I will say this is FAB away from the joint. Similarly, FAE, I will draw a line along the orientation and
AE.
let us assume that this angle is, as I have given everything is 3. What can be the angle? If this is 3 meter and this is 3 meter, what about this angle?
45.
45 degrees, isn't it?
Yes, sir.
Tan equal to 1.
1.
So,
Tan 45 equal to.
now tell me, which force I can find it out directly? Look at along x direction. Along x direction, how many will be there? FAB.
1, sir.
Along x direction, FAB.
FAB is
Component of FAE will also come into the picture.
yes, sir.
So FAE also will come, FAB will also come. We cannot find out any of directly. Instead,
But y direction?
now tell me, 5 kilonewton is acting on the downward direction, isn't it?
Sir.
This FAE,
FAE sign.
represented. If I resolve it along y direction,
Yeah.
the component is coming in which direction? If I resolve it along, if I resolve this component, what I will get?
Minus, sir.
What is this component? FAE cos 45. If I represent
FAE my
sin 40. My vertical force 5 kilonewton is acting in the downward.
Yes, sir.
Balance it. FAE 45 should act in which direction?
Downward direction.
Should act in upward, right? Then only it will be balanced.
Yes, sir.
Yes, sir.
Vertical component of FAE should acting in vertical direction. Then only it will balance this 5 kilonewton.
Yes, sir. Yes, sir.
So that's why instead of representing in the downward direction, what I can do? Can I represent it in
Upward.
like this? What does it mean? My FAE is under compression or tension?
Tension, sir.
The arrow. My arrow is represented towards the joint or away from the joint?
Towards the joint. So it will be compressive.
Compression. So if I write down summation upper equal to 0, what it can be? Or even you can do like this only, doesn't matter. As it won't deviate. Let it like this only. Along y direction, 5 kilonewton downward direction, plus FAE sin 45 is also downward direction. So FAE sin 45 is equal to 0. What is the sign of FAE then? Minus 5 by sin 45. What does this minus represents? Initially we have assumed it as a tension, but what is my FAE?
It's a compressive.
What is this value? 1 by root 2. 5 root 2.
Yes, sir.
That means 5 root 2 compression.
Compression, sir.
Similarly, now look at the forces along x direction equal to 0 then.
FAB cos 45 degree equal
Along
to
if I
0.
resolve it, FAB.
FAB.
FAB is truly oriented along x direction, so you don't have any component.
Yes,
Less
sir.
because of FAE cos 45 is equal to 0. That means FAB plus what is the FAE value? Minus 5 root 2.
5 root 2.
Substitute with the sign. Minus
5
5
root 2 into 1 by root 2.
1 by root 2.
Root 2 cancel.
FAB is equal to how much?
Minus 5.
Minus goes plus root
Yes,
2.
sir.
That means AB is under compression only.
Yes, sir.
Then this is what one way of shortcut. If any members are oriented like this,
Clear, sir.
if one member is known, if this member is known, if it is tensile, then what about this member?
Oh,
It it will be also in tensile position.
Yes,
If
sir.
it
Yes,
is
sir.
in tensile, it will be in tensile. As this angle is 45 degrees, that's why in a lucky we have got this value is equal. Sorry, did I mention it is 5, right?
Yes, sir.
Yes, this angle is 45. This is also 5. This is also 5.
Same.
So if your angle is 45 degrees, if one of the either horizontal member known or vertical member force is known, then the other one will also will act in the same magnitude. If not, then but at least you guys understood, right, how you can solve it. Now let us come to the joint B. Again at joint B, how many members are connected again? 3. Let me represent those members. At joint B, already FAB is known, tensile. So draw a line away from the joint 5. Similarly, FAC, draw a line away from the joint. Similarly, FAE, drawn a line and represented away from the joint. Now, which force I can directly know? I can directly know all the forces. Why? Because there are no inclined members, isn't it? What about
Yes,
this
sir.
value? What about the force in FAE?
FAE 5√2. 5√2, sir.
Sorry, this is it 5√2? Sorry, FAE, no, not 5√2. This is FBE, right? So this is FBC. We have resolved the forces at joint B.
You can find, sir.
What is the value of FBE? Along vertical direction, how many forces are there?
5 kilonewton, sir.
Along vertical direction, how many forces are there?
Only one, sir.
Only one.
Then,
0, sir.
if I write this equation, how many forces are there? Only one. That is.
Equal 0. Yes, sir.
Now look at the forces along horizontal direction.
FTC equal to 5.
The 5 is acting on the left side to balance this. FBC should act on the right, and this component should be equal to 5. Here the logic is here. This is what our most common questions in our gate or in ECE, that you guys have to identify the 0 force members. Okay. Now, let me give you 3 different cases. This is member A, member B, joint C, joint D. Forget about other cases. Again, this is joint A, B, C, D, A, B, C, sorry, joint K only. Let me take testing otherwise. Now tell me, if I resolve the forces at joint A, how many forces will be there? 3, isn't it?
Sir, 3, sir.
FBAB, FAC, FAD, isn't it?
Sir.
Now, if you look at the along horizontal direction, how many forces will exist?
1.
What is it? FAD. Then what is the force in this member then?
0.
0, sir.
0. What is the difference between this and this? I can say it's just a orientation.
Yes, sir. Yes, sir.
Right. See, let us say, if I'm considering 2 different planes, X, Y, and then I am considering N and M. If I am saying summation of X equal to 0, summation of Y equal to 0, can you tell me what about the forces along the orientation N? What about the summation of forces along orientation M? What can be these 2 values? Did you understand the question? There may be a structure that is built up. For one time, I'm considering if I'm resolving the forces along X and Y. On the another case, I'm resolving the forces along some other orientation N and M. If I'm saying that forces along X and Y is equal to 0, what will be my summation of forces along the another orientation.
That will be 0.
Equal to 0, sir.
They will be equal to 0. That means if forces along two perpendicular directions are equal to 0, then you consider any different planes, any plane, any two perpendicular planes. It need not be truly along x and y. You consider any planes. Even then, the forces will be equal to 0. Understood?
Sir.
So, in the same way, I can resolve the forces along x and I can resolve the forces along y sometime. But in this case, if I say this is my axis n and if I say this is my axis m, what do
There
you
will be
think?
0, sir.
Which one is feasible? Will you write summation of fx equal to 0 or will you write summation of fm is equal to 0?
Fm equal to 0. That is feasible only.
Right? So this is feasible. Why? Because all the members are oriented along which direction?
M,
And
sir.
that's why no need to resolve any forces. But if you treat x and y, what is happening? No
Yes,
force is
for my
oriented along
assumptions.
x and y. That means if you want to find out the equation, you have to resolve this force, you have to resolve this force. So again, it will be a hectic thing. So always remember this logic. So if I resolve the forces along n and m, at this joint, the force here is equal to 0. What about here in this case? What about the force in member AC?
It will be resolved force.
It is not truly lying along x, isn't it?
Yes,
But
sir.
imagine if I resolve the force FPAC, what I will get here? Let us say this angle is alpha. FPAC cos alpha.
Yes,
What
sir.
about this here?
FAB
FPAC
sin alpha.
Then look at the forces along x. How many will existing?
2.
1, sir.
1. I'm sorry, sir. 1, sir.
Then what about this force?
Equal to
Equal
0.
0.
Then what we can conclude from this one, and this one, and this one? Can you conclude something?
Yes, sir.
What is Z?
N.
Can you please say it in words? That means if three members are connected at a member, if any two members are collinear, what is meant by collinear?
Straight line.
Straight line, sir.
Passing through the common line of action. See here, AB is also common collinear point. Here these are collinear. Here these are collinear, and here also these are collinear. If two members are collinear, and if there is no force acting at joint A, is there any force acting at joint A?
No, sir.
No, sir.
That means if two members are collinear, and if there is no force acting at the joint, then force in the non-collinear member. This is what the non-collinear member.
AD.
The force in the non-collinear member will be equal to 0.
Yes, sir. Clear,
Okay.
sir.
If
Yes, sir.
three members are connected at a joint, and out of those three, if two members are collinear, just like these two are collinear, just like this is collinear, and just like this is collinear.
Yes.
If any two members are collinear, and if there is no force acting at the joint, then force in the non-collinear member will be equal to 0. Right?
Yes,
Now,
sir.
if I just simply modify the same thing, A, B, C, and this is the member D, and imagine that there is some applied force here. Can you tell me what is the force in member AD?
Right side 10 kilonewtons, sir.
10 kilonewtons.
10
Is it
kilonewtons.
0?
No, sir. Not 0. Sir.
So this is where the difference. If there is no load acting at the joint, then only will be equal to 0. If
Yes,
there is
sir.
a load acting at the joint, then
Not it will be equal to 0.
here VAD is nothing but a 10 kilonewton. Right? Now go to our problem and let me just rechange the diagram. In the part B, in this part, let us assume that I have given like this, just for the simplicity. Now, resolve the force or reconsider the free body diagram at joint C. Let us say this is D. What is the force in member BC? Draw a line, and I'm representing away from the joint. Similarly, drawing a line along CD, I'm representing away from the joint. Now, if I apply the equilibrium equations, can you tell me how much you will get it?
2.
Can you tell me what is the force in this member and what is the force in this member?
No force, sir. No force.
0, sir.
0.
That means again we can say at a joint, if two members are connected, and if there are no loads acting at the joint, then what about the forces in the members?
0.
What about if the forces are acting like this? Again, in this case, can I say that or not?
Yes, sir.
Again, the same thing.
Yes, sir.
Again, two members are connected. There are no forces acting at this joint. Then again, say force in member C is equal to force in member D.
D is equal 0. Yes, sir.
Clear?
Clear, sir.
So just like this, you have to go joint by joint and then you have to find out the answers. Now, quickly, can you tell me what is the force in member EF and what is the force in member CF?
EF will be 0, sir.
Now, at F, how many forces are connected?
A big
How-
joint, sir. CF or EF.
CF and P, isn't it? And
Yes.
EF is also there. Out of them, any collinear members?
No.
Collinear. If we see P, yeah, P and CF, they are acting on the same line of action.
Yes, sir. Yes, sir.
And what about the non-collinear member? EF. Is there any
EF
force
is not
there?
there.
Is there any force along the
No,
X?
sir.
No.
No, sir.
That means what about the force in this member?
0.
0.
0. Then what about the force in member CF?
CF will be no force acting on. No force. No.
CF.
Sir.
5, sir.
Sir,
5.
5, sir. 5.
Compression or tension?
Tension.
This is where it matters. Compression or tension.
CF.
Now imagine, I should draw a line, isn't it?
Yes, sir.
And then I should represent an arrow away or towards the joint. Here my arrow is in which direction? Force. P equal to pi is in upward. How can I balance it?
Downward.
So if I represent a downward force, it is towards the joint or away from the joint?
Toward. Away from. Toward the joint, sir.
Towards the joint. That means it is under tension or compression?
Compression.
Compressive, sir.
Compression. Okay.
Yes, sir. Clear, sir.
Shall we wind up today and shall we continue from the next class? So as of now, we are clear. Method of
Yes, sir.
joint,
Clear, sir.
and then we have discussed the how to find the zero force members. Okay. Before coming to next class, just go through this stuff and we will solve some problems on identifying zero force members, and then we will want to see method of sections, and then we'll wind up the determinator structures on next class. Okay.
Okay, sir.
Okay.
So somebody asked doubt, sir.
Sorry. Can you please ask again?
Can you solve previous class commerce. Sir.
Can you please type it because I'm not able to hear you properly. Or somebody please help me.
Can solve
Sir?
previous year questions are not possible. That
Sir, sorry, can you please come again?
sir, previous class you can give one homework problem, sir. That
Yeah, okay. Have
that
anybody
will solve
solved?
or not, sir?
Have you guys solved it?
So you can clarify once, sir.
You try. Next class I will clarify.
Okay, sir.
Let me try it from your side. Let's try it from your side and then I will explain you. Don't worry.
Okay, sir.
Thank you, sir.
Thank you guys. Thank you.
Thank you, sir.
If
Thank
I
you, sir.
continue, then it will be in between. So let's wind up here and then we'll start it.
Okay, sir. Thank you.
Thank you guys.
Thank you, sir.